Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I welcome you to the next session of the C refresher video lectures. Today we are going to have a review of how we can allocate and deallocate memory on heap. Before we start, let us see how an executable program looks like when loaded in memory. Let me try describing you this on the terminal. Heap management. Not exactly heap management, but we'll just learn how to allocate memory in heap, use it, and then deallocate it. Many a times, gentlemen, we have talked about the logical view of a process. The low memory in the bottom and the high memory addresses at the top. At the very top we have the command line arguments and the environment variables. Then we have the stack, which is used to store stack frames or activation records of function calls. Each stack frame or activation record contains local variables, return addresses, and the parameters that are passed to the function. As we call functions, the stack grows down, and as we return from the stack, as we return from the function calls, the stack shrinks. So stack grows downward and shrinks upward as function call and they are returned. For details of this, I will recommend that you should go to the C refresher lecture on GNU debugger. In the bottom we have the code section, normally called .txt. Then we have the data section divided into two parts, .data and .bss. .data is also called the initialized data. All the global, static and constant data resides here. This is read from the program file. And this is the uninitialized data, block started by symbol. Anyway, we are main concerned right now about what starts above the data section, and that is the heap. Unlike stack, heap grows upward. Dear students, normally we use heap in our C programs if we do not know how much space or how much data variables there is we will need at runtime. Some of you might have used a function that is alloc_a. You might have used this function to allocate this much number of bytes at runtime in the colors stack. But the limitation of this memory is that it do not survive the return statement of the function in which this is called. That is, it is freed automatically when the function that has called alloc_a returns. Anyways, today we are not going to compare the pros and cons of creating variables inside stack and heap. Rather, we are just going to concentrate on as how we can allocate memory on heap over here, how we can use it, and then how we can free it. Remember, you don't have to free the memory inside the stack. it is automatically freed. That is why the variables that are created on the stack are known as automatic variables. On the contrary, the variables that you create on the heap, actually you are responsible to free them. Almost all languages provide support for using heap or dynamic memory allocation. Most of you might have studied the new and the delete operator in C++ for allocating and freeing memory in heap respectively. But today we are going to use CMalloc function and free function for the same purpose. Let us move on the terminal and have a view of the main page of these functions. The malloc family of functions is composed of almost 4 calls. The first is the malloc call, which allocates this much bytes, size bytes inside the heap, and on success returns a pointer to the allocated memory, and on failure it returns null. Let me before moving ahead show you this on over here. Let's suppose that I want to call malloc and I want to allocate 20 bytes inside the heap. The malloc will return a void pointer, and I need to cast that to the appropriate data type. Let's suppose I need to keep character data in this memory, and I'm going to store the return address in a variable, let's suppose str. It is a better practice that instead of giving a number over here, you tell that I need this much number of, I want to use this memory for this much number of character variables. You can use int over here, which means this much number of integer variables. So in case if I use character, and on this machine character takes 1 byte, so if size contains 20 bytes will be allocated on heap. And if I use an integer over here, an integer on my machine, let's suppose take 4 bytes, then 4 into 20 is equal to 80 bytes will be allocated on heap. So it is a better practice to mention this over here. Okay, now remember, this variable will be created on stack. Suppose over here this variable is created, and this variable is, let's suppose the name of this variable is str, and this contains address of some place in the heap. Let's suppose this is heap. This is that place that has been allocated for us. The starting address of this 20 bytes memory in heap is returned to this str. So after this line of code, I can use str, I can dereference this address and access this memory. I can do pointer arithmetic with this str and access this memory. Another point to note is that once the function in which this line of code has been written returns, the stack shrinks. and this variable str goes out of scope. In that case, this memory is not accessible to your program. However, it will remain allocated, which is not a good practice. So it is always better that whenever you allocate memory using malloc, you free it using the free call. And to the free function, you always pass the address which has been returned by malloc, that is str. Once you execute this function, this memory will be freed. Although the pointer still points to this location. Although the pointer is still pointing to this location. And this pointer goes out of scope when the function returns. So this is how memory is allocated and deallocated on the heap. We can simply say that the memory on the heap is unnamed memory, which can be accessed using the address returned by the malloc family of functions. Okay, so now let me move back to this. After having understood what malloc is and what free is, let me talk about realloc. If you want to change the size of a previously allocated memory on heap, in C++ there is no renew operator. However, some of you might have used your programming skills to increase the size of the existing array on heap. You might have allocated the new block of memory using the new operator, then you might have copied the old block memory contents into the new memory, then you might have deleted the old block of memory and let the pointer of the old block of memory point to the newly created block of memory. But in C, you don't have to do all this because the realloc function is there to help you out. The realloc function increases the size of an already achieved heap memory that is pointed to by this pointer to this size. So it is very common to increase the size of a memory that is already allocated to your program. However, you should be watchful whenever you are trying to decrease the size of an already allocated memory, because that might result in the loss of data. Finally, the fourth function is the calloc. Malloc family is used for primitive data types only, and if you want to allocate space for structures and objects, you can use calloc. To calloc, you tell the size of that object and the number of the objects for which you need that memory for. So after having this brief overview, let us move and start coding. First of all, let me move on to creating integer arrays. Let us suppose that we want to create an application that prompts the user for some integer or floating point values and store those values in an array. The main point is that at program time or compile time, we do not know the exact number of values that the user may enter. So for that reason, we cannot create it on the stack, so we create it on heap. To save time, I have keyed some C programs that describe some important basic concepts related to dynamic memory allocation. So let me move on to the first program. Let me vim it 1d.c. So let's review the code, run it, and understand the logic. Over here you see I'm just prompting the user to enter the size of the array, and after that I'm using the malloc family function to allocate this much size on the heap. Malloc returns a pointer which is casted to an int and received in ARR. Remember, this ARR variable, which is of type int asterisk, is created on the stack, while this much memory has been allocated on the heap. This ARR is pointing to this memory as shown over here. This ARR over here, or str, is pointing to the memory on the heap. malloc in case of failures returns null, and once this memory is allocated we can print the values inside this memory. And remember, the variables created on a heap are automatically initialized to 0 normally. Over here in this loop I have input that much number of integers, and finally I have displayed those integers. Before exiting, or after I have used this memory, I'm going to free it. This is important, otherwise I may have memory leakages in my program. This is a very basic program. I have just tried to create a hello world program so that you can know how you can create 1D integer arrays on the heap. Let me compile and run it. I want to enter 5 values. The initial values are initialized to 0. Let me enter the values 1, 2, 3, 4 and 5. So the elements of the array are 1, 2, 3, 4, 5. I can create arrays of any size using this technique. Now let's suppose that I have already created an integer array of size 5. I want to increase its size. Let's suppose 10 within the program. So this is a program that do this for us. So first of all, I am going to get the size, initial size of the array, integer array. Then I have requested the operating system to allocate me that much number of bytes for storing integers inside the heap. Then I have prompted the user to enter the values as I have done in the previous program as well. After that I have displayed those values on the screen. Now the new logic is I want to grow it. So it is simple in C as compared to C++. I prompt the user to enter the new size and I call realloc. Remember, there are 2 arguments that are passed to realloc. The first is the pointer, which is pointing to the previously allocated memory on heap, and the second is the new size. And if it is a success, you have the resized array. If you print the resized array now, you will get the old array and the new slots will be populated with 0. Finally, remember, you must free the arrays. Let me compile it, run it. Let's suppose initial size is 3, 1, 4 and 19. And let's suppose I want to increase the size to 5 now. So the array is resized. You can see this is an array of size 5 with initial 3 elements are the same as the old array and the next 2 elements are initialized with 0. After having seen the integer arrays, let's talk about the character arrays as well. In a very similar fashion, we can deal with the character arrays, but remember, while handling the character arrays or strings in C, you must be very watchful as far as the basic I/O functions are concerned. If you haven't taken the previous session of Terminal I/O, I will recommend that you should listen to that video lecture and practice programs in that video lecture first. So let's review the code of this program. The user is prompted to enter the size. Enter the size of the string you intend to receive from the user. Then remember this getChar, because after scanf, the size has been received in this variable size. However, the \n is still there in the input queue. So we need to eat that so that it should not disturb to the fgetS function. After we have received the size from the user, I have allocated this much number of bytes in heap, and the return address is received in this line. And over here I've used fgetS to read from the keyboard this much number of bytes in the buffer line. As we have done before as well, fgetS has placed the new line character as well in this buffer line, which we need to remove. Here is a very elegant logic that removes this. strchr is a string function that scans this line for this character. So it returns the address of the location where it first encounters with the new line character, and we replace that address with a null. Finally, we print that line on the screen and then free the memory. Simple, quite similar to the integer array. However, be watchful. You must not miss this getChar to eat the new line character in the input queue. And you must remember, after fgetS, you must replace the new line character with the null character. So I just say 100. So I can enter a sentence of 100. Learning C is fun with Arif but. Okay. Well, the limitation of this program is that it really looks odd to ask the user size of the name or size of the string or size of the address that he or she wants to enter. A program running and prompting the user the number of characters you want to enter. So I need to know how much characters I want to enter actually. Let's suppose the user has entered 1000 over here and has entered just 20 characters over here. So that means almost 79 bytes are wasted. Similarly, if a user has entered 10 over here and later on has entered 11 bytes over here, or even 10 bytes, the program will crash. A good solution should be that once we run the program and the user starts typing the input, the array should keep on growing automatically as the user keeps on entering the characters. If I enter 5 characters, the array size should be, let's suppose, 6. If I enter 100 characters, the array size should be 101. So no space is wasted, and it doesn't prompt the user to enter the size of the array. How we can do that? Let me write down the concept over here first. Growing string on heap. Okay, what I personally believe is the step one is I'm going to get one byte on heap and place a null on it. So that if the user doesn't enter anything and presses enter without pressing any other character, so I have a one character array. Next is I read character by character. I read a character. If it is a new line character, I break. And if I see if this is the first character that the user has entered, then what I do is I allocate 2 bytes on heap. Otherwise, if this is a second character, I resize. I resize the array that has been created over here to something plus 2, where this size is initially 0 and it will keep on increasing later on. Then I place the character which I have received from the user in the array or the buffer, and I repeat this till while the input character is not \n, and finally I'm going to place a null at the end. So this is there are a rough algorithm that I can think of growing a string, growing an array on the heap. Let's move on to the terminal and see what the actual code says. I have written it for you, growing string.c. So this is the first thing that I have done. I have created a 1 byte array on the heap and I have placed a null in it. And this ensures that if the user presses enter without entering anything, the program do not crash. If you do not write these 2 lines, the program will crash if the user just press enter. Then I create a variable bytes allocated, initialize it to 0, that user hasn't entered anything yet, a character ch in which I am going to get the character, and then prompt the user to enter a sentence or an address or a name of any size. Now this is the loop which is actually going to do the job for me. I get the character and I see if this is a new line, I break. And I see if this is the first character, this will be the first character if the first character of the line is null. In that case, I just create an array of 2 bytes. Otherwise, I reallocate. I reallocate this line to bytes allocated plus 2. And remember, bytes allocated initially contains 0, 0 plus 2. Over here, I am going to write this character inside the buffer. And I am going to repeat this loop till the end, till I encounter a new line character. So this portion continues reading the input using getChar and placing that input in this buffer, and finally once it encounters \n, it comes out of this loop and places a null character wherever bytes allocated variable points to, and finally it prints that line on stdout. And since this is a very hello world program, we free the memory allocated. So this is a very beautiful program that you will be requiring most of the time. So I just say learning C is fun with Arif by no matter how much characters I type, it will automatically grow. It will keep on growing. I just say Arif. I say welcome to world of learning C. This is marvelous. Alright, gentlemen. One more thing as far as the 1D arrays are concerned is the array of objects. If you want to create objects array, the function is calloc. Let's suppose I have a structure student containing just two members, roll number and name, and I want to have 5 such students. I can receive this input from the user as well at runtime. So this is going to allocate memory in heap for this many number of objects, each object of size of S1. And calloc also returns null in case of error. After you have allocated memory inside heap for your objects, the rest of the task is quite simple. I am just creating or initializing roll numbers with 1, 0, 1, 2, 3, 4 or 1, 2, 3, 4, 5, the name of the students to default, and I am printing those values on std out, and finally I am freeing it. Remember, this is just a hello world program telling you how you can create these objects on screen or in your program. Once you are done with array of objects, the next task is, what if we want to work with the 2D arrays? Let me move on to my folder of 2D arrays, and again, first of all, we will talk about the integer arrays. This portion is a bit weak of the students. So let me take the board and describe the concept first. It's 2D integer arrays. Let's suppose that we want to create a matrix of size 4 by 3, 4 rows and 3 columns. A simple code snippet for this can be, let's suppose int rows is equal to 4 and let's suppose columns is equal to 3. So what I'm going to do is, let me change color and draw a diagram for you. I want to create a pointer that should point to another list of pointers. Zero, 1, 2, 3. These are the rows. This has to be a double pointer if this is an integer pointer. So you have the concept of double pointers. So let me use malloc. Change color again. Let me use malloc and say that I need this much numbers of memory. I need memory for this much numbers of memory where I need to store integer pointers. So size of int pointers, let's suppose on my machine is 4 bytes, that means almost 16 bytes. So it will of course return a double pointer, which I will receive in, of course, a variable, let's suppose table. So after this line of code has been executed, I have this variable table double pointer of integer type on the stack, and inside the heap I have these 4 memory locations. Now what I want to do is, I want that this should point to 3 memory locations, 3 columns, 0, 1, 2. This should also point to 3 locations. This should also point to 3 locations, and this should also point to 3 locations. So I need to run a loop. I need to allocate memory for this, then for this, then for this, and then for this. Let me write down a loop now. For, let's suppose I is equal to 0, and this loop should run for 0, 1, 2, 3 times. I is less than rows, 4, I plus plus, and I need to allocate memory for this. That is malloc, and this time size of an integer variable multiplied by calls, because over here I have 3 and over here I have 4. So once this loop, this instruction will be executed, once I will get this memory allocated. Over here, I have already table, so let me write table sub I. So first time table sub 0, that is this memory will be allocated. Next time table sub 1, this memory will be allocated. Next time table sub 2, table sub 3. So after this piece of code is executed, you will get a memory something like this. And once you have done using this, you need to free this memory, and then this memory, and then this memory, and then this memory. So I need to enter into a loop again. I is less than rows, I plus plus. I need to free table sub I. So when I contains 0, this memory will be freed. When I contains 1, this will be freed. When I contains 2, this will be freed. And when I contains 3, this will be freed. And when I contains 4, the loop will break. Now the portion over here has been freed from the heap. But remember, gentlemen, this portion is still there on the heap. I need to clear this portion as well. So I need to call free again. Free on table. So the memory which this is pointing to will be freed now. See? Once you write down this last free function, the memory will be freed. And once you come out of scope, this variable that has been created on the stack will automatically go out of scope and will be freed from the stack. It will be freed when the activation record of the function in which this is created returns. So after having understood the concept of how 2D memory is allocated on the heap, let's see the code. Okay, so this is more elegant function. I have created the init and the print function. Over here I am prompting the user to enter the number of rows and the number of columns, and then I am creating the memory as I have shown on the board as well. Then I'm going to call the init function, which is going to initialize these rows and columns, and then I'm going to call the print function, which is going to print these values. And then finally I'm going to free. The first loop will free all the actual data arrays, and this free will actually erase the arrays of pointers. Let's see this init function as well. This init function is passed 3 parameters: the address of the table array, rows and columns, so that we can run the loop rows and columns and prompt the user using scanf and assign values. And similarly you can see the print function as well, which just prints that array in a nice format, probably in a matrices format. Let me compile it and run it. Number of rows are, let's suppose, 4 as on the board. Columns are 3. So we need to enter 12 elements of the array. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, and then 11, and then 12. You see, it is displaying those 12 elements in a very elegant fashion. Well, this was about the integer arrays. The same way you can use 2D arrays of floating point values, but the important part is the 2D character arrays. Let me move on to the board again and talk about 2D character arrays. We are done with this, and 2D character arrays. We'll consider a scenario in which we want a program to prompt the user for names that may be long and that they may be short, having spaces in between. The number of names need to be specified by the user at runtime, and at the same time the maximum size of a name also need to be specified by the user at the runtime. So if I just draw the diagram to make you understand, is that this will be the variable, the double pointer of character type. Let me give it a name, names. This will first allocate memory inside the heap for keeping pointers, and we know this can be done using the simple malloc function call, to which we say size of a character pointer multiplied by let's suppose rows, and we return this by casting it to character pointer, and over here we have character pointer names. So after this line is executed, we have inside the memory a diagram that looks like this. Then I want that over here I should have a lot of space. Over here I should also have space, and over here as well, and over here as well, and so on. And for that, of course, I need to enter into a loop that will run rows number of time, and it will call malloc, of course, for size of character, not character pointer, multiplied by calls number of time. And by calls I mean the value over here, the maximum length of the string. And this will, of course, should be casted to a character pointer and will be received in names sub I. And of course I know how to free it. Let's move on to the terminal and see this running. Okay, so let's view the code and see it. I am prompting the user for the rows and for the columns, and since after that I am going to get a string using probably the fget as function, so I am eating the new line character that is still there in the input queue using getchar. Then I'm going to allocate the memory for rows number of names, each names of length calls. Then I'm going to prompt the user to enter name, and in this loop I am prompting for this much number of names, each name of calls -1, of course, length. And finally, I need to replace the last new line character with a null string. And after I have got all the names, I just print them on screen using this. And after I'm done doing everything, I free it. The same way I have freed the 2D integer arrays. Let me GCC this program. Let me run it. And I say I need to enter 3 names. And the length of each name is, let's suppose, 20. And the first name is Arif, but the second name is, let's suppose, Kakamanna. And the third name is Hadidur Rahman. So these are the 3 names which I have entered. Let me run this program again. I want to enter 3 names, and maximum length of a name is, let's suppose, 10. And I say Muhammad Arif Bhatt. And you see, the program has misbehaved. It has not prompted me for the second and the third name. And this is because the maximum length of the name is 10. So the array that is created for a name is of size 10, while I have entered a name of more number of characters. This is not good. So one idea is 3 and maximum length is 100. So this time this will work fine. But remember, inside the memory, the first name is also of 100 bytes, the second name is also of 100 bytes, and the third name is also of 100 bytes. Let me show you this on the board. The problem with this program is that we have 100 over here. Let me change color. We have 100 over here. So irrespective of the number of characters that has been input by the user, the array has been created of 100. Maybe the user has just entered 5 characters name, but the memory that has been allocated is of 100 bytes. So what actually should have been done is that names should point to this, and this should contain as many number of names as the user wants to enter. And let's suppose if this contains just Arif, it should be like this. If this contains Muhammad Rauf, so this string is of size 1, 2, 3, 4, 5. This should be of size 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and almost 14. This is a better technique. So you can always copy paste the code that we have done before, that is the growing string. Let's see if I have a program written for that as well. Yes, I have. Let's quickly view this. So this time I'm just asking for the user for the number of names, not the size of the names. Get charge, you know what is this for. So I have allocated the memory, and this is the memory for this. The first array is this. Let me okay. So after that, after allocating the memory for the array of pointers, so this is the code which I have just copy pasted from the previous code, and I have written this outer loop for each name. These outer loops run for each name, and this is the basically outer part where the memory is allocated, and this is the part where the memory is allocated for each name. And finally, for each name I am placing a null at the end, and then of course this is just displaying of that part, and then freeing memory is the same. Let me run this program, and you see 3 names: Muhammad, Arif, but, and the second name is just, let's suppose, Mansoor, and the third name is, let's suppose, Muhammad Rauf, but. So this time only this much memory has been allocated for the first name, this much memory for the second name, and this much memory for the third name, which is a far better practice. Okay, so students, how to handle memory leaks using the wall groin and electric fence that I talked about. I will discuss those in some later session, inshallah. That is all for today's session, and I expect that you will do lots and lots of practice for this. Write down these Hello World programs yourself and make minor changes with these, and try writing bigger programs. I wish you all the best. Happy coding and Allah Hafiz.